Okay, this is part 3 of our series on cross products, or our playlist on cross products, I should say. In the last video I showed you how to calculate the cross product A cross B using the brute force method. This video we're going to look at the determinant method, which is a little bit more elegant and definitely easier and less to keep track of as long as you're dealing with vectors with only two or three components. So the first thing I'm going to do is I'm going to write A and B with the added term plus 0 k hat. Plus 0 k hat, just to make it a little bit more obvious what I'm doing. And now I'm going to rearrange some terms here in the form of a matrix. In row 1, I'm going to have my unit vectors, I, j, and k. And I should point out that the point of this video is not to teach you how to take a determinant. I'm assuming that you already know that. If you don't, you can find that somewhere else or come talk to me in my office, that's fine. But if you know anything about determinants, this is just a method to refresh you and show you how it works taking the cross product. So row 1 is my unit vectors. Row 2, since I'm crossing A into B, row 2 is going to be the coefficients of vector A. So I'm going to have 3, 4, and 0. And my row 3 is going to be the coefficients of vector B. Remember, it's very important. Order is very important here. Since I'm crossing A into B, row 2 is A and row 3 is B. If I were crossing B into A, it would be reversed. Row 2 would then be B, and 3 would be the coefficients of A. But in this case, I'm going to put the coefficients of B here. 2, so minus 5, and a 0. I'm going to set this up in matrix notation. And also, I'm going to go to a different color, and just above these rows, I'm going to write this. Plus, minus, and plus. This is a sign convention that comes from just basic matrix algebra, and I'll explain what we're going to do with that in a second. And now, to determine the cross product, all I need to do is expand and find the determinant of this matrix. And so, again, if you don't know how to do that, please come talk to me in my office, or you can find it in any good calculus textbook or online somewhere. But all I'm going to do here is I'm going to expand about the first row. So let me move to a different color just to refresh you what I'm doing, not that color. So for I'm going to multiply this diagonal, the product of that diagonal, minus the product of this diagonal. Let me do that again just to make sure you got it. I'm going to multiply I times the product of this diagonal minus the product of this diagonal. And hopefully you can see that 4 times 0 is 0, minus 5 times 0 is 0. So what we're going to come up with there is just a 0. And then, without writing a sign, I'm going to move down since I'm running out of room, and I'm going to do the same thing, expanding about j. And so, I can't draw nice clean diagonals on this one, but what I'm going to do is I'm going to multiply this component by this component, and then subtract that product from this component times this component. Let me do that again so you see what I'm doing. And basically, this times this minus this times this. Notice I'm skipping the two numbers that are in the column that my j unit vector is in. I'm skipping those. I'm basically taking them out of the equation and just dealing with the numbers that are left. And like I said, if you know anything about matrices and determinants, that makes some sense to you. But again, in this case, what I get is a big 0. Now I'm going to move down again and do the same thing about k. So in this case, I can again show you explicitly. I'm going to expand 3 times negative 5 minus 2 times 4. So what I get in that case is it's going to be a minus 15 minus 8. And so what I come up with is, of course, a minus 23 there, which I write explicitly. But first, let me talk about signs. I wrote in this plus and minus and plus above this for this reason. We have to assign a sign, if you will, to each of these individual components or individual quantities that I've come up with. So the first one, I have a plus here. So on my very first product here, I get a plus. My next one, I have a minus here. So on my next one, I get a minus. My third one is a plus, so I get a plus here. In this case, it doesn't make any difference because these two guys are 0. But in general, if you're not dealing with such nice, clean, tidy vectors with no k components, those will not be 0, and you have to follow the sign convention, or you will get the complete wrong answer. That's the toughest thing about this method, is remembering the signs. But if you can do that, if you can remember that you just start with plus, and then it alternates, plus, minus, plus. And if there are more terms, it would keep alternating. It would go plus, minus, plus, minus, plus, minus, on to however many vector components you had. So in this case, these guys just go away, and what I'm left with here is a minus 23k, which is the same answer we calculated a different way. That's a very quick and dirty introduction to, hopefully it's not an introduction, but a quick and dirty explanation of calculating the cross product using the determinant of a matrix. If none of this makes sense to you, if you've never seen matrices or determinants before, please feel free to come talk to me or find that information elsewhere. But if you're moderately familiar with this, it's a pretty simple way to calculate the cross product of two vectors. Just remember your signs and remember your order, and everything should be good.